and welcome to another video. To solve this logarithmic equation, the first thing I will do is to express 64 in terms of base 2 as 2 raised to the power of 6. Then I'll bring the power here to become the multiplier of the log. Then after that, I can now apply one of the properties of logarithms known as change of base, because for the base to match each other, that's for the base of these to be 2, then the only way to do that, to make the base of the two logs match each other, is when we use one of the properties of logarithms. All right, so step number 1 is to write this write this in terms of base 2. So we have log to base 2 of y plus log to base y of 2 raised to the power of 6 equals to 7. So now I can bring this here to become the multiplier of the log. So that this will be log to base 2 of y plus 6 multiplied by log to base y of 2 equals to 7. Okay, now I can apply one of the properties of logarithms. Now using the property log to base a of b equals to 1 over log to base b of a. So this would be log to base 2 of y plus 6 multiplied by 1 over log to base 2 of y. Because for log to base y of 2, that will be 1 over log to base 2 of y. And this will be equals to 7. Now let's make a substitution here. That is, I'm going to choose a letter from the alphabet to represent log to base 2 of y. So now let's make k equals to log to base 2 of y. So that this will be k plus 6 multiplied by 1 over k equals to 7. Now, in this case, because I want this equation to become a quadratic equation. Okay, so what I will do is I'm going to multiply through this equation by what? Letter k. So k times k, that will be k squared. K multiplied by 6 over k, that will be 6. K times 7, this will be 7k. Then I'll bring this over to the left hand side, so that k squared minus 7k plus 6 will be equals to 0. So this is a quadratic equation. Okay, now this quadratic equation can be solved by using what we call factorization by splitting the middle term, and that is with the coefficient of k squared is 1. So we need two numbers that multiply towards 6, and when added together will be -7, and that will be minus 1 minus 6. So in this case, this will be k squared minus 6k minus 1k plus 6 equals to 0. So which means if we have k squared -6k, okay, minus 1k plus 6 equals to 0. So to write this in factored form, now I'm going to divide this by k. K squared divided by k, that will be k, minus 6k divided by k, that will be minus 6. Then this will be -1 parenthesis k minus 6 equals to 0. So that this will be the product of k minus 1 and k minus 6. So which means k minus 1 will be equals to 0, and also k minus 6 will be equals to 0. So the first value of k will be 1, and the second value of k will be 6. So now we have two values of k. Now these two values, we are going to use it to solve for the values of y. Okay, that will satisfy the given equation. So let's recall. We know that log to base 2 of y is equals to k. So case 1, when k is equals to 1, when k is equals to 1. So it means that log 2 base 2 of y will be equals to 1. And from here, we can say that y will be equals to 2 raised to the power of 1. And then the value of y, which is the first value of y, will be 2. Okay, then also case 2. That is when the value of k is, when the value of k, when k is equals to 6. So it means that because we know that log 2 base 2 of y is equals to k. Okay, so now we have the value of k to be 6. So which means that log 2 base 2 of y will be equals to 6. And from here we can have that y will be equals to 2 raised to the power of 6. Then the value of y will be 64. So the two values of y which satisfies this equation are 2, y equals to 2 and y equals to 64. Now let's verify. So to verify, we have that the first value of y is equals to 2. And the given equation is log 2 base 2 of y plus log 2 base y of 64. Now, will it be equals to 7, which is on the right hand side? Now that the value of y is 2, so this will be log 2 base 2 of 2 plus log 2 base 2 of 64. Log 2 base 2 of 2 will be 1, then plus 60. Now log 2 base 64, that will be log 2 base 2 of 64 will be log 2 base 2 of 2 raised to the power of 6. Then I'll bring this here to become the multiplier, so that this will be 1 plus 6 log 2 base 2 of 2. Log 2 base 2 of 2 is 1. 6 times 1, that will be 6. So which means 1 plus 6 equals to 7. Okay, and it means that the value of y, which is 2, okay, satisfies the given equation. Okay, so when y is equals to 6, okay, this will be log 2 base 2 of 64. Okay, when y is equals to 64, it means that we're going to have log 2 base 2 of 64 plus log 2 base 64 of 64. And we know that log 2 base 2 of 64, we can write that to be log 2 base 2 of 2 raised to the power of 6. Then log 2 base 64 of 64 is 1. So this will be 1. Then I'll bring this here to become the multiplier. That is, this will be 6 log 2 base 2 of 2 plus 1. And that will be 6 plus 1 equals to 7. So which means the two values of y, okay, that will satisfy this equation are y equals to 2 and y equals to 64. So the values of y, okay, which satisfies the above equation is y equals to 2, then y equals to 64. I'll see you in the next video. Bye.